Now that we have mastered how to factor simple trinomials using the product and sum method from last unit, we are going to take a look at how to factor complex trinomials. So a complex trinomial is a quadratic relation in standard form that has an a value that is some number other than 1. Okay, so the example here we have is 3x squared plus 5x plus 2. Now, we did take a look at some examples like this last unit. However, when we had those examples, we could common factor all three terms by the a value and get nice whole numbers. But if I were to try to do that in this case, I would be dividing everything by 3. And you will see that that is not going to give us nice numbers. Okay, so we would have our 3 out front, right? And then in the bracket, we're going to have 3 terms because we started with 3 terms. So 3x squared divided by 3 is x squared. That one is fine. But if you divide 5x or just like 5 by 3, you're going to have 1.666, continue on forever. So like 1.67x, that's a gross number. And then 2 divided by 3 is 0.667, whatever, continue on forever. That is gross as well. You cannot do that, right? In order to be able to common factor, we need to have a whole number when we divide. And you're not going to have a whole number when you're dividing things by 3 most of the time. Okay, so we cannot common factor for this, so we need to use a different method. So we're going to look at 2 methods of factoring these kinds of trinomials today. The first is crisscross factoring, and the second is decomposition. Now, both methods are acceptable to use. You may have seen one before or both before, kind of just depends, like if you've taken the course before, or I know like I've seen some of you use decomposition already. That's fine, you can stick with whatever one you know. Some teachers prefer one over the other, some teachers don't like you to use one versus the other. But honestly, as long as you know how to factor it using one of the methods, it's fine. I personally prefer crisscross factoring. I had never seen it until recently, but I like it a lot better than decomposition. You might like decomposition better, that's totally fine. As long as you have a method that you understand fully and that you are confident with getting the correct answer every single time with, then you can stick with that. Okay, so I am going to show both methods. I'll show crisscross factoring first. I find that this method is easier, especially if you have trinomials with like really big numbers, and decomposition can be faster sometimes if the numbers are smaller, but they both work totally fine. And there is a learning curve with both of them, so if you are a little bit confused, just practice, try along with me, keep trying, keep practicing until you decide which one you like best. Okay, so the first one, crisscross factoring, what I'm going to do is I'm going to write the trinomial again here. So I'm using 3x squared plus 5x plus 2. And what I want to do is I'm trying to think of 2 terms that will multiply to give me the first term here. So 2 things that will multiply to give me 3x squared. And I'm going to write them below. So both terms are always going to have an x in them because x times x is what gives us that x squared piece. And then I need to think of 2 numbers that will multiply to give me 3. In this case, it's nice because there's only one option, 1 and 3. There's nothing else you can multiply to make 3, so I'm going to write those numbers here. It doesn't matter which one you write where. Typically when I'm doing this, I won't write 1x, I'll just write x, but for the sake of this, I'm going to show this here. Okay, and the reason why I'm doing this is because 1x multiplied by 3x is going to give me that 3x squared term. Okay, so now I'm going to take a look at my last term here, this 2. I don't need to worry about the fact that it's positive right now. I will worry about that later. And I want to think of 2 numbers that would multiply to give me 2. Okay, so in this case, we've got 1 and 2, or we can also use 2 and 1. Okay, in this case, it does matter the order of them, and you'll see why in a moment. Okay, so let's say I want to go with 2 and 1 first. I would write those below there. And then what I'm going to do is I'm going to draw a crisscross. That's where this method gets its name from. Okay, so I'm going diagonally between my numbers here, making that x in the middle. And what I'm going to do is I'm going to multiply following my arrows there. Okay, so the first one here, I'm doing 3x, and then I'm following that arrow, and I'm going to multiply by 2. Okay, so I'm gonna show this in pink here. I don't typically show this when I'm doing this method, but I will because we are learning. So 3x times 2, and then I'm gonna write that product beside the 2 here. So that gives me 6x. And then I'm doing the same thing with the other numbers. So I'm gonna do 1x times 1, and that just gives me 1x. Okay, so I'm multiplying following my crisscross, and you want to make sure that you write them in the same spot. So like 3x times 2, write it beside here. If you put it down here or like swap them, you're going to get your answer all mixed up. So just don't do that. Okay, so follow the arrow like here, 1x times 1, write the answer beside it. Okay, and now what we want to do is we're taking a look at the middle term, which is plus 5x. And I want to see, can I make 5x from adding or subtracting these terms here, 6x and 1x? Which, if you're looking at this, yes, you could, right? If I had this is plus 6x and minus 1x, that would give me plus 5x. However, the reason why I wanted to show you this example is because this case, this is actually like a trick answer. Because once you've done that, what you want to do is you're taking a look at your signs here and seeing if they make sense. Okay, so if we look at the C term, this is positive 2, which tells me that my two signs here need to either both be positive or both be negative. Okay, right? Because similar to with the simple trinomial factoring, we're going to use these signs in a moment. And so when we're using them, they're going to be multiplying. And if one's positive, one's negative, it's going to give me a negative C value. And I don't want that. I want it to be positive. Okay, so these two terms need to either both be positive or both be negative. So if I made them both positive, that would add to give me 7x. If I made them both negative, that would add to give me negative 7x. That's not going to work. Okay, so I don't want to use those two terms in that order. Okay, so obviously 1 and 2 are the only factors that I have to multiply to make 2, but I don't want them in that order. Okay, so I'm not going to use this one, which means I have to use this one. That's my only other option. Okay, so instead of writing 2 and 1, I'm going to write 1 and 2. You might think, why does that even make a difference? But I'm going to show you why. So now I'm going to multiply again. So I'll do 3x times 1. That is going to give me 3x. Then I'm doing 1x times 2. That gives me 2x. And then I'm seeing, can I add or subtract those to give me positive 5x? And yes, I can, right? If I do 3x plus 2x, that's going to give me plus 5x, which is a match. Okay, and like I said, I need to put my signs here. So plus 3x plus 2x will give me plus 5x. And because they are both positive, that will work out when I go to multiply to make this a positive as well, okay? So then what I'm going to do is I take that positive sign that I wrote on the top beside the 3x, and I'm going to write it on the top between these two numbers. And I take the positive sign that I wrote on the bottom with the 2x, and I'm going to write it between the numbers on the bottom here. In this case, it doesn't matter because they're both positive, so there's no way you can mix it up. But it does, you want to make sure that you're putting the sign from the top on the top, the one from the bottom on the bottom, especially if you have one negative and one positive. Okay, now this, I know before I kind of explain what the factored form looks like now, it might seem like, okay, well, I don't like that because the trial and error, like, well, I didn't want to have to write that and erase it. No good. Which is how I felt when I first saw this method as well. I thought that's like too much guessing and getting things wrong. But I promise the more you practice this, the better you'll get at like, even if you write your factors here, the better you'll get at just kind of doing that initial crisscrossing in your head and thinking, does that work? No, let me try something else. It's fine if it takes you a bit to kind of get it to click. It did for me as well, but now that I know how to use it, it's my go-to method. So just do whatever works for you in the beginning, like show more steps if you need to, write things out, cross them out, erase them, try again if you need to. But like I said, once you get the hang of it and once you've like been practicing your multiplication skills like this, it will come a lot easier. Okay, so we've put our signs in here, the plus signs. Then the last thing is just to write a bracket like this on the top and one on the bottom. And then our factored form looks like this. We have equals. I'm not going to write 1x, I just write x plus 1. Okay, I'm just reading left to right on the top there. That's my first bracket. And my second bracket is 3x plus 2. And that is my factored form. Okay, so it's as easy as that. The main thing is just like making sure you have your numbers in the right spot to crisscross. But once you do, that is how you write your factored form. And it's totally fine if you like had put 3x on top and the 1x on the bottom. Similar to with the previous unit with factoring, it doesn't matter what order your brackets end up going in. Like you could have them like this. As long as the contents of them are the same, then that's fine. Like this is the same factored form. And the great thing about factoring is that you can always expand to check your answer. Sorry, so you can expand it and you should get the same, the exact same answer as what you started with. So that's the nice thing about factoring. It makes it easy in that sense. Okay, so let's take another look at crisscross factoring and how we can use it. In this case, I showed you like that trial and error with like the incorrect example because I wanted to show you what would happen if the answer, like if you tried the wrong example, or if there's kind of like a trick answer that you might think is right. But like I said, once you get practicing, you will find that you don't really need to show that every single little detail as much. Okay. So the next example that I'm going to look at, I'm going to have 35x squared minus 90x minus 45. Okay, so right off the bat, we can see these are way bigger numbers than what we're used to dealing with. Typically, we have like pretty small numbers, especially for our A and B values. In this case, we do not, which is fine. What we always want to do first is we want to check, can we common factor some number out of all three terms, because ideally we want to make the number smaller if we are able to. Okay, so I'm looking at 35, negative 90, and negative 45 and trying to see if there is a greatest common factor. So what I'm noticing is that they end with 5 or 0, which tells me that I can divide by 5 for sure. And then if I can divide by 5, I want to see, okay, could I divide by 10? Which no, 35 and 45 are not going to divide nicely by 10. I might then say, could I divide by 15? Which no, 35 is not going to divide by 15. So we'll just stick with 5. Okay, so I'm going to divide each number by 5. This is just common factoring, which we learned from the multi-factoring or multi-step factoring video that you always want to common factor if you are able to first. Okay, so we'll put the 5 out front, and then we have three terms inside. So 35 divided by 5 is 7. The x squared stays the same. Negative 90 divided by 5 is negative 18. X stays unchanged. And negative 45 divided by 5 is negative 9. Okay, so that's just making the trinomial a little bit more simple for us to work with. And then we'll just check and see, can we factor any further here? So if I wanted to common factor this out, I would check, can I divide everything by 7? Obviously, yes, the first term you can, but negative 18 is not going to divide nicely by 7, and neither is negative 9. So I'm going to use crisscross factoring. Okay, so the first thing I'm doing is I'm trying to find two terms that are going to multiply to give me 7x squared. Again, I know they both are going to have an x in them. And then to multiply to make 7, my only options are 1 and 7, so I'm writing them there. It's fine if you write 7 and 1. Then I am looking at my last number, which is 9, and I want to find two numbers that will multiply to give me 9. I'm ignoring this negative sign for now, okay, and I'm just worrying about 9. So I'm going to write them over here. So I could have 1 and 9. I could have 3 and 3, or I could have 9 and 1. Okay, so again, it's a little bit of trial and error, but the nice thing is, like, if you go through and try, like, let's say you try the first one and it doesn't work, and then you try the second one and it does work, you don't have to keep going. Okay, so like sometimes if your number is like 12 or 24 or something bigger, you'll have a lot of options for your factors. You don't need to try all of them. Once you find one that works, you're good. And typically, it's not always the case, but typically they're the numbers that are closer together, especially if you're working with really large numbers. That's usually the one I try first. Okay, so I'm gonna try 3 and 3 first to see if it works. Spoiler alert, I know it works. It's okay if you try 1 and 9 or 9 and 1 first and it doesn't work. Just for the sake of time, I'm going to show you with 3 and 3. Okay, so I'm going to write 3 here, and I'm drawing my crisscross. And I'm going to multiply following that crisscross. Okay, so on top, I'm going to do 7x times 3. That gives me 21x. And then following the other arrow, I'm going to do 1x times 3, which gives me 3x. And now I want to see, can I make 18 from 21 and 3? Again, I'm not paying super close attention yet to the negative sign. I'm just looking, okay, 21 and 3. If I were to add them together, I'd get 24. So that's not going to work. However, I can see here, this is a negative 9. Because it's negative, I know that one of these is going to have to be negative, the other is going to be positive, in order to give me that negative sign when I'm expanding again. So I can either have negative 21 and positive 3 or positive 21 and negative 3. You can use some other kind of like context clues, like the fact that this is negative tells me that the bigger number needs to be negative, but also it's easy to just check. Like if this was positive, this was negative, you'd have positive 18. So we're going to do the other option. If this is negative 21x plus 3x, that's going to give me negative 18x, which is what I want to match. So that's what I'm going to do here. Okay, so then what I'm doing is I take the signs that I have. So here I wrote a negative sign on top. So on top right here, I'm going to write a negative sign and a bracket. That's my first bracket. On the bottom beside the 3, I wrote a plus. So I'm going to write plus on the bottom here. And then this is my second bracket. Okay, so when I write my fully factored form, I need to make sure that I bring, like I took this common factor out at the beginning, so I need to write it here. Otherwise, your final answer is not going to be completely correct. Okay, 5, and then I'm just writing my brackets here. So again, you can write 1x if you want. I just write x minus 3, and then 7x plus 3, and that is your final factored answer. Okay, so like I said, make sure that you practice lots. There is quite the learning curve with this, but once you've got the hang of it, it's pretty straightforward. If you don't like this method, then take a look at decomposition and see if you like that method better. Again, whichever one you prefer, stick with that one, and you'll get the same answer. So stay tuned. I will show the same questions, but using decomposition. All right, so we are going to take a look at the same example, 3x squared plus 5x plus 2, but using our second method, decomposition. Now, this method is called decomposition because we are going to decompose or break apart the middle term, the bx term. And we want to kind of see, okay, how can we rewrite that middle term? Instead of plus 5x, we want to write it as a combination of two terms so that the first one will have something in common with this term, the 3x squared, and the second one will have something in common with this plus 2. Okay, so what I mean by that, I'm just going to look at just all of these numbers are positive, so I'm just going to look at strictly positive examples. So if I could have like x and 4x, that would add together to give me 5x. I could have 2x and 3x, that would add together to give me 5x. Then I could also have 3x and 2x, or 4x and x, okay? It might seem like it doesn't matter here what order you put them in, but it does, and I will show you why. So essentially what we're trying to do is we want to split this 5x, we want to write it as two terms so that I can make two different pairs. I want whatever the first term is here, I want it to have something in common with my ax squared term, meaning I want it to either have a 3 with it or be a multiple of 3. And then the second number that I am rewriting this with, it needs to either have a 2 or be a factor of 2 because I'm going to split them into groups to common factor. Okay, so if I'm looking at my options here, x, that is not 3 or a multiple of 3, so we're not going to use that one. 2 is not a multiple of 3 or 3, so we're not using that one. But this is, right? 3x is the same, like that's 3 and 3. And this one, 2x and 2, those have something in common. So I'm going to pick this one. Okay, and what I'm going to do then is I'm going to rewrite this expression, but instead of plus 5x, I'm writing in those two terms that are equivalent to plus 5x. Okay, so I am making the equation temporarily bigger. It has 4 terms now instead of 3, and I'm going to show you why in just a moment. Okay, so now what I'm going to do is I'm going to create 2 pairs of 2. Okay, so this first group and this second group, and I am going to common factor in just those pairs. Okay, so I'm going to common factor with the first 2, and I'm not worrying about the second 2 at all. I'm looking to see what is in common between 3x squared and 3x. So 3 is obviously the biggest number factor, and then x is the biggest variable factor. So I'm going to divide both of those by 3x. And what that will look like is this. So when you common factor, you put your factor that you're dividing by out front, 3x. And then in the bracket, I should have 2 terms because there's 2 terms in that pair there, the one that's underlined in pink. So 3x squared divided by 3x gives me x. 3x divided by 3x gives me 1. Okay, so that's what that first part is going to factor to. It looks like this. Then I'm going to do something similar with the second pair, the one underlined in blue. I want to find something common between 2x and 2, which is just 2. Okay, you can't divide by x because there is no x in the second term, so you're just dividing by a number. The sign you write in the middle is going to be the same as this sign here, right? So I had a plus here, so I'm going to write this as plus 2. 2x divided by 2 is just x. 2 divided by 2 is 1. Okay, so that is my common factored pair for the second one. And what you now notice is I have x plus 1 in this bracket and x plus 1 in this bracket. So what happens is I'm going to common factor once more. But in this case, the common factor is x plus 1. Okay, because both pieces here have x plus 1 with them, which means I can divide them both by x plus 1 or factor it out and simplify a bit further. Okay, so in this first pink term, if I'm dividing by x plus 1, that's going to cancel this out. When I'm common factoring, I write my common factor out front, x plus 1, and then I'm going to have a bracket, and I had 2 terms to start with here in the previous line, so I should have 2 terms left in the bracket. So if I cancel out that x plus 1, I'm left with just 3x. And then in the second pair here, if I divide by x plus 1, that's going to cancel out, and I'm left with just plus 2. And that is my factored form. Okay, so the exact same answer is what we got with crisscross factoring. Some of you might think that this is actually simpler than the crisscross factoring for this example. I agree that it's probably about the same difficulty for this one. And the numbers were pretty small here, right? Like I had a 3, a 5, and a 2, which are pretty small. So I'll show an example with the big numbers again, just so you can see how decomposition works with that. But again, essentially what you're doing is you are rewriting the middle term as a combination of 2 other terms, and you choose those terms based on if they have something, to make them have something in common with the ax squared term, and the other one to have something in common with the c term, so that you can common factor, get the same thing within your brackets, the same binomial, common factor again, and then you get your fully factored form. All right, so let's take a look at one more example of decomposition, this time using the same example number 2 that I did with crisscross factoring. So again, the numbers that I'm starting with are quite large. so the first thing that we want to do again is just check if we can common factor. Because we already did this example, we know that we can. We're going to divide all three terms by 5 just to make them a bit smaller and easier to work with. Okay, so when we common factor, we always write the number we're dividing by out front of the bracket, and then inside the bracket there should still be 3 terms. Okay, so we'll have 7x squared. This was negative 18x, and then negative 9. Okay, so this step is the same as the first step with crisscross factoring because it doesn't have anything to do with the new methods. It's just common factoring first to make our trinomial a little bit smaller. And now what we are trying to do is we are looking at this middle term, the negative 18x, and we're seeing how can we rewrite that in two terms that, like where the first one has something in common with 7, so it's going to be either 7 or a multiple of 7, and the second term has something in common with 9, so it's either 9 or a multiple or a factor of 9. So last time when we looked at this, like in the first example, it was easy just to split it up, right? It was 5, so we could easily just say, okay, 1 and 4, 2 and 3, 3 and 2, 4 and 1. Because this is a negative 18x, our options are a little bit different here. So we don't necessarily have to split it into, like your first thought might be, okay, I'm gonna do, if I want the first term to match up, like the first thing I'm splitting into to match up with the 7x squared, you might try to say, okay, what if I have 7x? And then if you did that, the other term you would have would be negative 11x. However, in this case, like the negative 7x would work here with the first term, but negative 11x and negative 9 do not have anything in common. Okay, so you have to think of another way you can rewrite this term. And I guess when I'm saying, like, decomposition to me means like, oh, let's split it. But when you think of splitting, you might think of it in the sense of like you have to break it down into two smaller numbers. But what's going to happen in this case is we are actually going to split this or rewrite it like this. So we're going to rewrite it with a negative 21x. I know you're probably like, what? Where'd that come from? And a positive 3x. This case, you might think, okay, how did I just get that? It's a lot of like trying to do like a bunch of mental math and figure out what's going to work, or trial and error on your calculator. I know that this needs to be one of them negative and one of them positive because this last term here is negative. Okay, so if your C value is negative, then you know that you're going to have a mix of signs here, sort of similar to in the crisscross example and similar to when we did simple trinomial factoring. But yeah, so that's how I know. So because this is negative here, I need to have one term negative, one term positive. And because my answer here ends up being negative, that's telling me like the bigger term that I'm rewriting it with is going to be negative, and the smaller term will be positive, because that's like this negative 21x plus 3x is still giving me a negative number. And this will work because 21 is a multiple of 7. So that will be able to be common factored. And then 3 is obviously a factor of 9. So that will be able to be common factored as well. Okay, so I'm going to rewrite this here as 5, then I'll have 7x squared minus 21x plus 3x minus 9. Okay, so I'm splitting it up there, and again, I want it so that the terms are going in the spot that will pair them up with something that can be divisible by. Okay, so I've got this first pair, the 7x squared and negative 21x. So I'm going to think of, okay, what can I common factor those by? So like I said, they're both divisible by 7, and they're both divisible by x. Okay, so I'm dividing them both by 7x to common factor here. So then you'll bring the 7x out front, and then inside, if you divide 7x squared by 7x, you'll have x. And then if you divide negative 21x by 7x, you have negative 3. Okay, so that's what the first pair ends up being, is this term here. And then you're looking at the second pair, so this positive 3x and the negative 9. And again, this pair, typically you're just dividing out a number. So the number that's in common here, the greatest common factor is going to be 3. So I'm going to write plus, the 3 goes out front, and then in my bracket I'm writing the terms that I divide by. So 3x divided by 3 is just x, and negative 9 divided by 3 is negative 3. Okay, so that is what I get from common factoring my second pair of terms. And again, similar to last time, you will notice inside the bracket, you end up with the same binomial, okay, the same two terms there. So what I'm going to do then is in this one, I'm going to divide by x minus 3. And in this one, I'm going to divide by x minus 3 to common factor once more. Okay, so this is going to cancel out here. I'm going to have equals, this 5 needs to stay out front the whole time. Okay, so that's one thing that's a little bit different. So I will have x minus 3. You don't have to write the double bracket this time now just because of what's happening here. And then in your next bracket, you will have two terms, okay? So in the first one here, the one that I underlined in pink, if we cancel out that x minus 3, we're left with just 7x. And then in the second pair here, the one underlined in blue, if I divide by x minus 3, that cancels out, and I have just plus 3. Okay, and then this is my fully factored form. Again, it's the same as what I got when I used crisscross factoring. The difference here is that for me personally, this piece, trying to figure out what the two numbers are that you're going to break the middle term down into or rewrite as, that is more confusing, not even confusing, but more time consuming for me to figure out when the numbers are larger here. Okay, so with the first example, like I said, the numbers were smaller, so it was a lot easier to come up with your options for how you could rewrite the 5x. In this case, to be honest, the main reason why I knew it was going to be this and this is because I already did the crisscross factoring example first and I knew what the end result was going to be. So that helped me to kind of figure out what was going to happen here and here. Okay, so that's not to say that this method is wrong, or like obviously it's not wrong, the answer is right, but it's not to say it's like the lesser of the two methods. I just personally prefer the crisscross method because once you common factor down to this, you're just trying to find things that multiply to 7 and to 9, and you don't have to worry about like any adding and subtracting to make these numbers, because when you're finding things that will multiply to 7, there's only one option, right? 1 and 7, and things that will multiply to 9. Again, you only have a couple options. Whereas when you're trying to find numbers that will add and or subtract to give you the middle term, there is technically an infinite number of options, because with adding and subtracting, like you could do, like it could be 1 and 17 or 2 and 16 or 3 and 15. Like there's so many options. Obviously you have some hints like with this to kind of guide you, and you know that the numbers need to go with the 7 and go with the 9. But in my opinion, this method leaves more room for making mistakes, or even just is not as efficient if your mental math is not top notch. So again, it's up to you which one you prefer. I would mark both of them correct as long as the answer is actually correct. So what I always tell students is pick the method that you know you can get the answer correct 100% of the time, or at least that you can be confident with using. So don't just pick whatever one I say I like best because I say I like it. Pick whichever one makes most sense to you and that you are confident with solving, that you know it inside and out, and you don't need any sort of like reassurance or extra help with like, how do I do this? What are the steps? Because they are both different in the way that you set them up. But once you practice them, there's a learning curve, and once you figure it out, once it clicks, it'll be kind of like second nature, and you will find which one works for you, and you'll need it. You'll need one that you've mastered, because like I keep saying, you will need to be able to factor um, as like a basic math skill in your grade 11 math class next year, depending which one you end up taking. And if you take grade 12 math, you definitely will need to be able to factor like this, and it is an expected skill. So make sure that you practice, do all the practice questions. I know there's a lot of them, but practice them with the method you prefer so that you can master either crisscross factoring or decomposition.